So if we want to learn GD&T from completely basic, means from completely zero, at very first we have to understand two things. One is feature and second is feature of size. Most importantly, regular feature of size. Because without understanding of feature of size and also without knowing the difference between feature and feature of size, we cannot understand GD&T first rule, GD&T Rule 1. And if we do not understand GD&T Rule 1 in beginning, then for us GD&T will become a language without its grammar. Means we will use the symbols and control without understanding of its actual meaning, without understanding of its actual application. But to understand the GD&T Rule 1, we have to understand one more very important concept of actual mating envelope. Too much confusion, isn't it? Like, which things should we understand first? So let's start with an example, and with that example, first we will understand the overall concept of everything together and also how they are connected to each other. And then we will understand each of one in depth. So let's say we have a part with a hole of diameter 20 plus minus 0.5 mm. And we have to design a shaft which should be passed through this hole in all the conditions. Here these diagrams looks like rectangle block, 2D block, but assume that these are three-dimensional. This is a cylindrical shaft and this is a cylindrical hole. Okay, so diameter of this hole is 20 plus minus 0.5 mm. And as the shaft should pass through this hole in all the condition, means this shaft maximum size, maximum diameter has to be less than a smallest possible size of this hole. I'm repeating, if this shaft should pass through this hole in all the condition, then this shaft maximum size, maximum diameter has to be less than the smallest possible diameter of this hole, so that this shaft can insert it into this hole even if hole is produced at its minimum diameter. Minimum diameter of this hole means 20 minus 0.5, 19.5 mm. So we can consider the shaft diameter anything less than 19.5 mm. So let's consider shaft maximum diameter 19.4 mm, 0.1 mm less than the hole minimum possible diameter. And at the lower side, let's consider the shaft diameter is 19, means 19 plus 0.4 and 0 at lower side. So even at the worst condition, means if the shaft is at largest size 19.4 mm and hole is at lowest size 19.5 mm, even then at least 0.1 mm of clearance will be always there. Here the 0.1 mm clearance is too much loose, but this is just for demonstration. Now, after the manufacturing of this shaft, if we will take the measurement with vernier clipper or micrometer, the diameter of this shaft can be slightly different at different points. Or we can say at different section of the shaft, something like this, 19.2 at point A, 19.1 at point B, and so on. But all the measured diameters should be within defined tolerance limit, 19 to 19.4. And in GD&T world, there is a specific term for this measured size, the actual local size. An actual local size is the measured value of any individual distance at any cross-section of a regular feature of size. What this simply means is whatever we measure with a vernier clipper, the outer diameter of the shaft or inner diameter of the shaft, or the thickness of a plate, or the size of a slot, all are actual local size. Because we always measure an individual distance at individual cross section. And there is a limitation of actual local size measurements. Actual local size measurements does not ensure part assembly, the part fitment. For example, here each local sizes of the shaft are under defined tolerance, under 19 to 19.4. But we cannot ensure that this shaft will always go through this hole, because in some cases this shaft can be manufactured with a bend, something like this, around their axis, or maybe something like this. And this is not a crime because we haven't mentioned that the shaft should be straight or how much it should be straight. We have only defined the size, the diameter of the shaft with tolerance, and the diameter is maintained within its tolerance limit at every cross section. Means vernier clipper measurement will pass this part. With vernier clipper, we cannot prove that this part is rejected or bad, but the shaft may or may not be assembled, depending on how much the part is bent or deformed from its perfect shape. So how we can confirm that this shaft will be definitely assembled? So we can simply say if this complete shaft can come under a cylindrical envelope of size 19.4 mm diameter, then this shaft will be confirmed assembled in this hole of 19.5 mm. No matter that how much shaft is bent or distorted in any shape, but it should fit into this cylindrical envelope, or we can say this cylindrical boundary of maximum diameter 19.4 mm, the upper limit diameter of this shaft. Because this whole minimum diameter is 19.5 mm, but actually this hole can be also bent or distorted, something like this, in manufacturing. So even if this shaft is under a cylindrical envelope of diameter 19.4 mm, it might not pass through this hole. So this hole should be within cylindrical envelope, but actually it should be inverse. Means any portion of this hole should not come under a cylindrical envelope of diameter 19.5 mm, the lower limit of this hole diameter, something like this. And we call this envelope or the boundary actual meeting envelope. Actual meeting envelope of an external feature of size, like of this shaft, is similar perfect feature counterpart that can circumscribed around the feature of size, so that it just contact the surface at highest points. As we can see, this external actual meeting envelope is contacting at only 3 points, which are the highest point of this shaft. And an actual meeting envelope of an internal feature of size, like of this hole, is a similar contact feature counterpart that can inscribed inside the feature of size, so that it just contact the surface at highest point. As we can see, this internal actual meeting envelope is inscribed inside this hole and touching only at the highest point. So in summary or conclusion, we can say to ensure the assembly of this shaft and this hole, all the actual local size of this part should be within defined tolerance limit. Means this shaft actual size should be within 19 to 19.4, and this hole size should be within 19.5 to 20.5 mm. But this is not enough. Only vernier clipper size measurement is not enough, because for assembly only size variation control is not enough. We have to also control the part form deviation within a limit. The form should be controlled within or around its actual meeting envelope. Means the diameter of this external actual meeting envelope of this shaft should be maximum 19.4 mm, the upper limit of the shaft diameter, or we can say mmc of this shaft. And the diameter of this internal actual meeting envelope of this hole should be at least a minimum 19.5 mm. The lower side of this hole diameter means mmc of this hole, which we will learn in next section, LMC and MMC. But here, how we can define these actual meeting envelopes in our drawings, in our manufacturing drawings, or how we can instruct that this mating part should not only pass the actual local size measurement, but also should pass the actual mating envelope measurement. So if you are new to GD&T and you have just basic, not basic, but you know all the symbols and controls, then you would say we should apply cylindricity control over the both hole and the shaft. Or some of you would say we should apply straightness, or maybe someone can say we should apply total runout. But what if I told you that actually we don't have to apply any control? We do not need to control the form of these geometry with a control feature frame. What we have to do is only specify that this drawing is made in ASME Y14.5 standard, GD&T drafting standard, in the drawing title box. Because the moment when we mention the drawing are made in ASME Y14.5 standard, 16 fundamental dimensioning rules automatically invoked that apply to dimensioning and interpreting engineering drawings. Plus 2 GD&T rules, Rule 1 and Rule 2 applies by default until we do not override the Rule 1 and Rule 2. And the GD&T Rule 1 is a dimensioning rule and refers as envelope principle that ensure that individual regular feature of size will be assembled with one other. Rule 1 establishes an overall boundary, or we can say envelope, for a regular feature of size that is equal to its MMC, maximum material condition. Because the GD&T Rule 1 states the form of individual regular feature of size is controlled by its limit size. So according to GD&T Rule 1, for an external regular feature of size, the maximum boundary or the envelope will be equal to its largest size limit. Like here, the largest size limit of the shaft is 19.4 mm. And the form of the shaft will be controlled within this envelope limit. And for an internal regular feature of size, the minimum diameter of envelope will be equal to its minimum size limit. Like here, the smallest size limit of this hole is 19.5 mm. And the form of the shaft would be controlled around this envelope. Because the GD&T Rule 1 state the form of individual regular feature of size is controlled by its limit size. This means the form of this shaft and this hole cannot deviate beyond its defined limit size. So the form of these parts are controlled by GD&T standard itself, by GD&T Rule 1. So to ensure the assembly of this part, we don't have to define an additional controls. And this is something where GD&T with Rule 1s is kind of give a relaxation to a designer, that we don't have to worry about the fitment if we haven't controlled the form of individual feature of size. We just have to define the proper fitment tolerance. The form of the geometry will be automatically controlled within its limit size. But if you have noticed, many times I have mentioned two terms. One is feature of size and one is regular feature of size. Like actual meeting envelope of an external feature of size. Yes, the actual meeting envelope is only defined for a feature of size, not for the feature. And most importantly, GD&T Rule 1 definition, the form of an individual regular feature of size is controlled by its limit size. So yes, GD&T rule once applies to only regular feature of size, not to the feature of the part or not to the irregular feature of size. So this is very essential to know that what is feature, what is feature of size, what is regular feature of size, and what is irregular feature of size. And not only that, also many GD&T terms like bonus tolerance, virtual condition, regardless of feature of size, maximum material condition, least material condition is only applies, only defined for a feature of size, not for the feature. And most importantly, MMC and LMC modifier may only use to where the feature control frame is applied to a feature of size, not to the feature. And certain geometrical tolerance may apply to feature of size, not to the feature. And certain geometrical tolerance may apply to feature, not to the feature of size. So let's understand these terms one by one. So the first is feature. So the feature is everything that can be touched. Or we can say that every surface of a part is a feature. Like this face, this back face, or this radius curved surface, this whole surface, everything is a feature. In GD&T, surface means feature. Nothing is complicated. Now, the feature can be also complex feature. Like here, this is a single surface, but it's a collection of curvature surface. But again, this is just a feature, not feature of size. So what is feature of size? Yes, the feature of size, not size of feature. What do you feel? So what do you feel when we heard this word for first time, the feature of size? Of course, it's related to a size or size of a feature or feature which has a size. So yes, a feature of size must associated with a size tolerance dimension. But feature of size is very general term. So feature of size is either referred as regular feature of size or a irregular feature of size. Regular feature of size is one cylindrical or a spherical surface or a circular element or a set of two opposed or partially opposed parallel elements or opposed or partially opposed parallel surfaces, each of which is associated with a direct tolerance dimension, size dimension. So let's decode it. So the first is a cylindrical, which means simple shaft or a roller or a circular hole with its direct defined size, with its diameter. It's all a regular feature of size. A spherical surface means a spherical ball, or we can say a spherical ball cavity within a part with its diameter. So it's a regular feature of size. Yes, a regular feature of size can be external as well as internal. Like a shaft having a cylindrical surface, so it's an external regular feature of size. And a hole having also a cylindrical surface, so it's an internal regular feature of size. Quite simple. A circular elements. So for example, let's say this shaft has a groove cut, something like this, or also can be something like this. So this line is a circular element and having the size, so it's also a regular feature of size. And now to understand this set of two opposed or partially opposed parallel surfaces, regular feature of size, first we have to understand the concept of opposed surfaces. And there can be three possible opposed surfaces in a part. One can be completely opposed surface, or one can be partially opposed surface, and one can be non-opposed, or we can say offset surfaces. And in GD&T language, two parallel surfaces are called completely opposed if all the rays normal from each planar surface interact to other surface. As we can see in this diagram, the face A and B are completely opposed surface. This 20 plus minus 0.5 mm width of this cube and this slot of 20 plus minus 0.5 mm are completely opposed surface and parallel surfaces. And if sum of rays projected normal from each planar surface intersect the other surface called partially opposed surface. Like here, some of rays are intersecting and some are not. So this width 5 plus minus 0.1 is a partially opposed and parallel surface. And when none of the rays projected from each surface intersect the other surface, it means it's a non-opposed. And as we can see, this both surface projects rays are not intersecting anywhere. So this is a non-opposed surface. And a regular feature of sides should have complete opposed or at least partially opposed surface or elements. Like this width, this slot, and this width are regular feature of sides. But this is not regular feature of sides. What about tapered surface? Is this regular feature of sides? So no, because these are opposed but not parallel. So this is not a regular feature of sides. The face has to be opposed but also should be parallel. And not only the surfaces, also the line elements can be a regular feature of sides. Means this whole, this line A and B are parallel and opposed. So this is also a regular feature of sides. So can these two edges of this cubic block be also a regular feature of sides? I'm not saying this, I'm asking you. So you can let me know in the comment. So let's say this is a cubic block of size 20 by 20 by 20 with a size tolerance plus minus 0.5 mm. So as the all surfaces are opposed and parallel to each other, so can we say that this complete square section, a square profile of 20 by 20 is a regular feature of sides and will follow the GD&T Rule 1? Means is this a square section 20 by 20, a square form will be under a size limit? Something like this? So the answer is no, but let's understand it. So the face A and B are opposed and parallel. Also the face C and D are opposed and parallel. So the width 20 plus minus 0.5 is a regular feature of sides and will follow the GD&T Rule 1. These both surface form will be within its size limit plus minus 0.5 mm. Means this will be parallel to each other within 0.5 mm plus minus 0.5 mm, and the height 20 plus minus 0.5 mm is also a regular feature of sides. So this will also follow the GD&T Rule 1, and this both faces will be also parallel to each other within plus minus 0.5 mm. But this overall square profile will be not maintained within the size limit. This can be something like this. Both height and width are parallel and following the GD&T Rule 1 because the individual size, height and the width are the regular feature of sides. But this square profile does not. This is not regular feature of sides. Same in case of hex section block. All the individual faces are opposed and parallel. So they are regular feature of sides. But this hex itself is not regular feature of sides. So this will not follow the GD&T Rule 1. So this was all about the regular feature of sides. A cylindrical shaft or a cylindrical hole is a regular feature of sides. A spherical ball is a regular feature of sides. A parallel and opposed surface are the regular feature of sides. Like the width of this rectangle or the thickness of this rectangle. or the width of this slot is a regular feature of size. And what are the not regular feature of size? This is a slot and having opposed and parallel surface, but this is not directly dimensioned with a size tolerance, so this may not consider as regular feature of size. This radius is not a regular feature of size because it doesn't have an opposed and parallel surface. Also, this is not completely cylindrical. This width is not regular feature of size because it doesn't have opposed surface. This square or hex section block are not regular feature of size. This complete slot is not regular feature of size. This random cut is not a regular feature of size. The outer diameter 80 plus minus 0.5 mm is not a regular feature of size because it doesn't have opposed parallel surfaces, and this is not completely cylindrical. But these all are irregular feature of size. A irregular feature of size does not require opposed surfaces or elements or association with a direct tolerance size dimension, but it must able to establish an actual meeting envelope. The first questions are coming in your mind is that a regular feature of size or irregular feature of size having the same status, having the same power, or we should treat them equally? So no, GD&T first rule only applies to a regular feature of size, not to irregular feature of sizes. As we have seen in cubic block example, the square profile is an irregular feature of size because it has an actual meeting envelope, but GD&T rule 1 only applies to the width and the height to a regular feature of size because they are set of two parallel and opposed surfaces. But other feature of size benefits are also given to irregular feature of sizes. So there are two types of irregular feature of sizes, type A and type B. Type A is one is directly tolerance feature or collection of features that may contain or may be contained by an actual meeting envelope, that is a sphere, a cylinder, or a pair of parallel plane. For example, like this 30 plus minus 0.5 mm is an irregular feature of size of type A. Doesn't have opposed surfaces, but having an actual meeting envelope of the pairs of parallel lines. Or this outer diameter 80 plus minus 0.5 is an irregular feature of size of type A, having a cylindrical actual meeting envelope. But an irregular feature of size may contain or contained by an actual meeting envelope other than a sphere, a cylinder, or pair of parallel planes as well. The type B irregular feature of size, like this triangle cut, is an irregular feature of size of type B. This slot is an irregular feature of size of type B, which are not contained by an envelope of cylinder or the pair of the parallel planes. They have an irregular envelope. And now, to be practical from this complete lesson, the one thing that I want you to understand as a design engineer is GD&T Rule 1 is an envelope principle, and GD&T Rule 1 only applies to a regular feature of size. And you got that what are the regular feature of sizes? Cylindrical shaft diameter is a regular feature of size. Thickness or width of a plate or slot is a regular feature of sizes. And you do not need to control the form of a regular feature of size just for sake of assembly or the fitment of the two parts. If you do not apply any geometrical form, the form will be within its size limit because that is the GD&T Rule 1. Apply the geometrical form control only if you need the precise form more than its size limit, its tolerance limit. Like cylindricity form control over a bearing shaft I hope you got my point. And now, sometimes we may have to independent the form of a regular feature of size from its size limit. Means we do not have to apply GD&T Rule 1. For example, let's say we have a mild steel cylindrical rod of diameter 5 mm plus minus 0.1 and the length is 1 meter. So as this 5 plus minus 0.1 mm diameter is a regular feature of size, GD&T Rule 1 will be applied by default. Means this 1 meter 5 mm diameter mild steel rod can bend only 0.1 mm throughout its complete length of 1 meter, which is not practical to manufacture. So we have to mention that here GD&T Rule 1 is not applying. Something like this. But GD&T Rule 1, also known as the perfect form at MMC. So in the next chapter, we will more deeply understand GD&T Rule 1. But first, we will understand MMC, LMC, and regardless of feature of size. So the next video should be on our screen, or you can check the description. And if you like the video, please do like the video and also do subscribe the channel because we are about to crossing 10K. Thank you so much for doing this.